Hello. Can anybody hear me? Yep. Hello.
Good afternoon, everyone. My name's Kate, and I'm a Business Development Manager in the CPD unit at Cardiff University. I'm really delighted to have so many of you on the session today, so thanks very much for joining us. As it said in the short video, we're going to take some questions towards the end, but please feel free to use the chat function as you go to ask questions that we can then post to the host at the end. So now all I'd like to do is introduce you to Dr. Luis Espinosa-Anke, who's going to be taking today's session. So thanks very much.
Hi, everyone. Thank you for the introduction. I think I'm going to share my screen and start the presentation. I'm very happy to see so many people. So hopefully we can make this a useful session. So let me see. I got two screens, so it's never easy. So I think, yep. This is right now. You should be seeing the set of slides. Okay. Well. I'll just say one thing about me, so you know a little. I can give you a little bit of context and where this presentation comes from and what's the motivation behind it. I am a lecturer in the School of Computer Science, but actually I have a background in linguistics. Mm, and I've been well. My area of research is specifically natural language processing, right? So this branch of AI that deals with human language, and as an as an artifact of human behavior. Um, well, when we study language in our research, most of what we find is a reflection of society, history, and well, many different factors, no, that go beyond having a system that is good at translating sentences from English to Spanish or from any other language pair, or which is good at detecting whether people are speaking well or poorly about a certain company or a certain politician in social media. Um, and well, in this context, no. One topic of interest for all of us, and if it's not, it actually should be, um, is the question of ethical considerations when we're dealing with data. And I said the title in the presentation specifically says AI, but you can port this to any discipline where data plays a major role. Um, and even within the community, it's kind of interchangeable using AI or machine learning. Um, or data science even, no, so anything that has to do with data will eventually have to face the reality of the world from which the data we analyze comes from, no. So this is the whole point of studying this aspect, which is not a technical angle to data science and AI, but it's definitely an angle that everyone, everyone, period, should keep in mind, because we're not oblivious to the use of technology, right? So all of us use it in one way or another. So this is a very personal take on we should care as practitioners and or users of technology. Um, so because this is, it's a very complicated topic, no, and it's difficult to give answers. And the answers are not going to come in this session either, I'm afraid. What we're going to do is to try to leave the session with as many reflective questions as possible, so that when we at least make sure that the time we spend together leave us with a critical outlook towards the use of technology and what happens now when we're actually interacting with technology. Um, and well, the first term, no, that I'd like to mention is the phenomenon of dual use, right? So this is something that every time a new technology has been coined into society, um, how to use that and the difference between the intended initial application and what actually it was used for, it usually differs, no, quite a bit. So the classic example that's been given in the literature is the example of electricity. So it turns out that electricity was invented in 1879. Only 2 years later, the first London streets were lit in 1881, but only 9 years later, the first man was executed with the electric chair. Um, it's very likely it's reasonable to assume that this application of the electricity was probably not in the mind of the scientists that were behind this invention and the deployment of electricity in London. But nevertheless, this is something that happened, and it became part of society. So this is not something that happened once in the past and that's it. It's something that has been carried over with many different technologies up to today. Now we are as I said, no, we deal with technology and with artificial intelligence algorithms basically every day, no. So every time we speak to the phone translates something for us, or we take a photo and we get this small box around faces. This means that there's a machine learning and AI system behind that has learned from examples. So it has learned to detect faces in photos by looking at many photos and learning what makes a face as opposed to a hand or an animal or a piece of furniture. And the ingredients to this, marvel are three, no? One of them is algorithms, so the actual set of instructions that you give the computer to, come up with um, some kind of learning or some kind of rules that it can apply to some scenario, some environment. Data, huge loads of data. So this is something that is very important, and we will speak a bit about this down the line. And computing power. So when you group these three ingredients, you have the perfect, you're ready to go for having well, to as much as we know today that can be done, today in terms of AI, if we have access to these three ingredients. And here we're talking self-driving cars or autonomous agents or video games that play themselves. No? Um, so why should we think about um, these ethical considerations and the notion of fairness as people working with data or as people consuming data? So I like this is a reflection that I think is very appropriate when if we ask ourselves what's the main difference between data science or any type of discipline that deals with data versus any other kind of scientific discipline. And it's actually the idea of opting in into an experiment or opting out, right? So let's take the medical sciences, for example. Usually, no, to test a drug, there has to be a certain sample of the population that needs to take the drug. There needs to be a control group, so other people who are not taking the drug, and there are some statistical tests that tell us whether the drug was effective or not, and whether the effectiveness of the drug or the improvement of the patients can be um, 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 the contribution was from the drug itself, and it wasn't, for example, a matter of chance. But it turns out that in data science, this is not the case, right? So we all are part of a permanent experiment run by large technological companies that use our data um, every day to improve their targeted ad algorithms, to improve how their speech recognition systems work, to improve their face detection images, even the CAPTCHA and reCAPTCHA um, um, authentication um, programs. They also are used under the hood to use the wisdom of the crowd to manually tag thousands, millions of photos. So it's not that, I mean, technically we could, no? We could technically leave this experimentation, but we would be missing a lot of the fun that technology gives us, no? So usually this is not something that we do, right? So because data science, and I want to highlight, no, the term science, no, the development of cutting edge technology, which is primarily designed for improving our lives. Everything, because there's access to so much data, there also has the door is wide open for introducing a matter of very heated discussions nowadays, which is the notion of bias. How do we deal with the fact that data may not be a true reflection of reality, and even if it is, whether we want that data to reflect that um, reality, if that would mean that we would be amplifying or at least perpetuating a certain situation, which from an ethical point of view may not be desirable. So there's a lot of discussion around bias. If you look for bias in AI, you will find that it's a heavily overloaded term. So because it's used for bias is a term highly ambiguous in machine learning and AI. It has a lot of meanings. Some of them are technical. Some others are more related to how the algorithms learn. And of course, there's the ethical bias in data. No? So we're going to focus on this last sense or meaning. Um, and surely, no, I mean, bias is not in itself a bad thing, right? So we all have our own biases, and this is something that we learn from the moment we're born. And often it's even, well, an instinct for survival. So if we're walking down the street, um, in which case, looking at these two photos, would we more likely to, cross the street and walk on the other side? Well, I guess the answer is quite obvious, no? But this is a survival instinct, no? So that's not something that anybody should be ashamed of. This is simply how the human mind works, no? So we have certain biases. Our mind, our subconscious makes assumptions to make our life better. Now, these assumptions, if you take them from the behavioral point of view and you take them from the behavioral, from the human point of view to the technical point of view, you end up in what's been called in the literature the no freelance theorem. So basically, this theorem, it's mathematically proven theorem that says that actually there's no such thing as the best algorithm out there. That's simply not something that's not even a thing. And actually, if you take all possible problems out there and you apply any kind of algorithm, their performance, so how well your algorithms would perform across the whole possible set of problems in the world, in the end, all algorithms would probably do similarly in an average way without having without seeing too many differences between them. And the reason for that is that one algorithm, one model is specialized for one task. And in order to be very good at doing one task, telling dogs from cats in photos, for example, it really has to make a lot of assumptions. And this is what's called in machine learning inductive bias, the inductive bias in machine learning. No? So let's say an algorithm has seen 1 million photos of dogs and 1 million photos of cats, and these were manually tagged. This is a cat, this is a dog. Now, please, you should learn what features make dogs different from cats. But it won't be able to see all possible dogs and cats in the world. So it will need to make generalizations. It will need to make assumptions. And these kind of assumptions, which is something rooted in the technical development of machine learning and AI systems, is something that is a good reflection of how we deal with of this phenomenon when we look at it from the behavioral human point of view. And so just to stop for a minute, I gave not this introduction to the notion of bias, but maybe surprisingly not straight to to what I would expect that most people in the audience would expect, but rather discuss also the term bias from a technical point of view. And this is something that it's becoming more and more relevant to us. for those of us doing machine learning, AI, but also for everybody actually dealing with technology. And the reason for this is because the more access all of us have to data, the more capable we are to deal data-driven solutions. But these data-driven solutions are, by definition, dependent on the type of data they have seen. And as you can see in this very nice plot, the number of papers discussing fairness in machine learning, and this is data taken from one of the top major conferences in machine learning, has skyrocketed in the last years. So let's talk about a couple of specific biases, no, that can have an impact, a negative impact in the development of AI systems. And hopefully by having a kind of an in-depth look into the different types of biases, we will be able to look critically at technology and the use we make of it, which I believe would be a very nice conclusion at the end of this talk. This is taken from a beautiful piece of work by Holdome III, book on machine learning from 2012. So highly recommend it, read. And he discusses more, no? So I've selected these three because I think they kind of summarize very well the coarse grain, no, the most important issues in AI and ethical considerations and ethics surrounding AI. Sample selection bias, bias in the problem definition, and bias in the features. And let's look at them. So what's sample selection bias? Well, as this name is quite self-explanatory. We can't really remember the example of, you know, the photos with dogs and cats. We can't really expect to have access to every single data point for a single problem, right? We can have access to a lot of data, but we cannot have access to everything. So we will have access to a subset of a population. And we should hope that that subset of the population gives us a representative distribution of the reality. But turns out that in many scenarios, this is not the case. And in the book, no, there's this very good example. Let me read it for you. It says, in criminology, the only people for which we have training data are those that have already been arrested, charged with, and convicted of a crime. And we'll see an example of this right here. No, so there was an algorithm being evaluated and tested some years ago on the likelihood of convicted people of recidivism, no? So to get out of jail and commit a crime again. And as you can see, this quite dramatic table was really showing a very big difference between white and African American, and between whites and African Americans, and it tended often to label as lower risk, even if they reoffended later, for whites than African Americans. And well, one of the reasons, the most obvious reasons for this was because most of the training data that came from the prisons from which this algorithm was trained, most of the population, at least the percentage of African Americans, was much higher than whites. So actually, this can be kind of tackled or addressed, and we'll see. We'll look into this a bit later on. You can have a bias, or you may be introducing bias in how you define the problem. Right? So let's take this. An intelligent billboard, right, on the street, maybe let's say next to a bus stop. It predicts the gender of the person walking towards it, has a camera, no, and checks us out and says, this is a male, this is female, so I'm going to decide which kind of advertisements I'm going to show. But it may be trained as a binary classifier, male or female, and thus it would be excluding anyone who does not fall in the gender binary. And this is something that as society progresses and becomes more aware of the difference of the different profiles and how humankind and humanity can be shaped in many different ways, shortly the products that are developed with technology should account for that progress. And this is something that could, this would be an example of bias in the problem definition. Or in the features. So when we speak about features, we speak about what are those outstanding characteristics, no? What makes a dog a dog? What makes a cat a cat? We throw a lot of examples into a machine learning, into an AI algorithm, and we let the algorithm pick up the most important features. So pointy ears, or in some type in I guess all cats versus only in some dogs, the shape of the skull, size, and so on and so forth. No. So here, what we need to look at is, are our algorithms, or are the algorithms that we're using actually looking at the right stuff for making predictions? Because it may very well be the case that the algorithms are looking at proxies for making the predictions, proxies that become more apparent, but which are not really tied to the problem itself. And here's an example. This was, a matter of heated discussions back in the day. Google Translate tended to translate sentences like this: the manager thanked the receptionist. It turns out that in Spanish, manager and receptionist, they both have gender endings. So by putting L in front of the translation of manager, you're implying that it's a male, and by putting la in front of the translation of receptionist, where you're inferring that receptionist was female. And surely, you don't have any context in that sentence to infer that. So the features that the machine translation system has learned are proxies, which are, if we read between lines, have to do with relations of power, frequency of the data, the fact that there are probably many more managers male in the training data that Google Translate used back in the day to deal with translations from English to Spanish. Doesn't mean that without any context, the manager is going to be more likely to be a male, right? So to avoid this is another example from Turkish, no? So the model assumed that o bir doctor would be translated to he and not she. Google introduced gender-specific translations to account for cases where, when we translate from one language to another, the gender gets detached, no? And and to ensure there's a fair treatment of different communities, something has to be done, right? This is from a recent-ish paper from Lahoti and colleagues from 2018, and they actually show that in the job website Xing, it was actually possible to find cases where profiles matching profiles applying for a certain position they were ranked, right, according to the scoring system of Xing. But if we look at the work experience, the education experience, and the profile views for many of these candidates, there's kind of a disparity between the scores and the actual ranking. And this can only be explained by the male and female column. So this was another case where, it kind of became quite known, this work, because it highlighted a lot of the biases that were encoded in these HR systems that did this kind of triage, or were used for dealing with massive influxes of resumes for open positions. Okay, so it's quite. I mean, it's quite. It's we can't really say it's looking bad because there are a lot of efforts being put by very strong bodies in different associations to deal with this. Right? But this is something that, as long as we have data, that's something that we need to look at specifically. Again, no, shortly as practitioners, but also be aware of these phenomena as users of technology. The ACM, which is the Association for Computing Machinery and one of the reference associations of information technologies out there, has this excerpt, no, in their code of ethics. They say that computing professionals should aim at minimizing the malfunctions of automatic systems, right? And specifically assess social consequences um, of any deployment in the real world of a system, of an automatic system. And I would add, especially if it has learned from examples. Um, so actually this is, it can be measured. So we can really measure how fair an algorithm is, but this is way out of the scope of this talk. So I'll just say a couple of things just to, highlight the fact that this is not only some chatter that's going, something that's floating in the air, but that's something that's been measured and addressed with the highest possible rigor in the machine learning and computing community. So there are different factors in which we can measure to assess fairness in models. No? And among them, we've got demographic parity and equal opportunity, no? As well as disparate impact and equalized odds. So they're grouped. The first two go in one group, and the latter two go in another group. So demographic parity means that the model should treat a protected population group at the same rate as the entire population. And the term disparate impact means demographic parity, but without the algorithm knowing there's a protected community that it should treat, it should pay more attention to. And I'll give a couple of examples in the next slide. For the case of equal opportunity, the classifier should have equal true positive rates on a protected population group as those of the entire population. And in a similar fashion, equalized odds is equal opportunity, but without the algorithm really knowing whether there's or not a protected population. So how does this translate as examples? No? So any system or any model, not necessarily computing, should ensure that, for example, the rate of hiring women should be at least 80% of that of hiring men, and that should be ensured even if the algorithm doesn't know that it's dealing with men and women as two separate communities. No, so only looking at features which are not proxies for um, well, the, the the properties of the population, which may not have anything to do with their skill set for a particular job. Let's say we're looking at we have an observatory, no, and we're looking at hate speech and crime online, and we're monitoring Twitter, and we say, okay, we want to be able to catch toxic comments, right, hate speech on Twitter. But that's fortunately a very small percentage of the whole activity on Twitter, right? So if we were to look, if we had an algorithm that was very good at predicting that the tweet is not hateful, and did not a very good job in predicting when an actual hateful tweet was actually hateful, it would still be objectively quite good. But it would be treating both problems in a very different way. So here, the notion of equal opportunities basically telling us we should be conscious and try to maximize the performance of any data-driven system for all the cases, even those which are rare, which are not very frequent, because usually those are the ones that suffer from being underrepresented in training data. Um, so if we think now of the responsibility of people like me, people who make a living dealing with data, um, how do we as a community approach this problem? And I guess this is I guess no, this is a very interesting reflection for those not being active practitioners well, data science, machine learning, and technology in general, because it's quite an eye opener. Um, so I don't know how many of you know Tate Tweets. This was a bot developed by Microsoft, uh, which was deployed in Twitter in 2016, and it was advertised as being a bot that learned how to communicate with humans by interacting with humans. And because people is, we are the way we are, as soon as the internet found out that they could influence the behavior of this bot, there was a massive amount of interactions with this bot, which were extremely racist, misogynist, just for the sake of it, because that's the internet for you. So what happened was that in less than 24 hours, this bot became a racist, sexist, classist. Yeah, he was some character, right? And it got disconnected in a day or two, right? They pulled the plug, and it really showed. There was a lot of discussion around what should have those Microsoft researchers have done, and should they have anticipated this, right? There are a few examples here, really, really, really. Well, speechless, no? Um, but it really opens the question, no? So to what extent someone dealing with data and doing research should be held accountable for this misuse, right? And there are a lot of factors, no? Um, so, it's increasingly easy to get some data and train an AI because it has been democratized, and the code for doing that is easier and easier to use. We live in an unclear situation between how and who regulates the usage and deployment of data-driven solutions, and of course, expectation management and responsible communication. So in the interest of time, I will only touch a bit on some of these, and I will spend a little bit more time in others, which I think are actual highlights in this session. So the black box approach, I think this only applies to those of us actually, dealing with code. But I think this slide summarizes very well. It's very it's a reality that it's very easy to end up training models without having a good intuition of what the data is telling us, because it's sometimes too easy to build an AI. And actually, very quickly, this is the result of a Kaggle survey. Kaggle is a platform for data science competitions, and people when they were asked, what do you find most difficult about ensuring that your algorithms are fair and unbiased, people actually gave the reason of data. So it was difficult for people who compete in these competitions to find enough data to train their models, such that these models treated minorities in a similar way as they treated the majority class or the most common population. The idea of accountability is really fascinating because it opens a lot of philosophical and political discussions. But let me just highlight this author, Leonelli. She's done a lot of work on this topic, and very clear, well, addresses these topics in a very clear way. And well, some of the conclusions now are more reflective questions, but I think this is very important, the last bullet point. So when we have data that our models train on, how can we ensure that this data has been labeled, ensuring fairness and eliminating unwanted biases? Because often that's not the case. And the reason is that it's data is gathered and collected automatically from user interactions, like when we use our phones. Um, and data science, AI, etc. This is a distributed discipline, from the people doing research in their labs to the engineers, the hardware, the cloud computing machinery, the data that we generate. So it's really difficult to identify and pinpoint, yeah, this group are responsible for this behavior of this model, and this group are responsible for this other behavior. So one of the proposals, because each individual perspective is unavoidably partial, and this is something that's well, it's just a proposal, but I believe in it, is to have a kind of a chain of custody in data. So from the time the data is collected to the moment the model or the algorithm is deployed in the real world, can we ensure that all the parties involved in the development of that system are made accountable for the part and the whole of the whole pipeline? And this is something that the neural, uh, just to show, no, um, to prove a point, major conferences are now asking authors that submit papers in machine learning and AI to highlight any societal impact that their systems may have. I'll just say one word about expectation management. Um, so a language model is a machine learning system that speaks, basically. It generates reasonably uh, sensible, grammatical, and semantically meaningful text. And OpenAI, one of the big guns in AI, some time ago released a press note where they said, we have developed a state-of-the-art system, a state-of-the-art language models, but we're not going to release it to the public because it can be used maliciously. Turns out that then, I think as it was at Stanford, one grad student invested a few $1,000s and was able to replicate the same model. But well, regardless of that, what happened then was that the media amplified that, and we ended up with headlines like this: Elon Musk founded OpenAI, builds artificial intelligence so powerful it must be kept locked up for the good of humanity. And if you look at the press note, I mean, almost they were almost asking for it. No, so this is the kind of amplification in the digital age that we are subject to, and of course with the mandatory photo of the Terminator. Um, so yeah, when this goes for both sides, no, if you deal with data, make sure that any kind of communication is made in a way that is responsible. And if we are consuming news stories and information about machine learning, AI, let's not buy into the hype, because most of it is, unfortunately, I mean, this is a state-of-the-art model, okay? So this is something that has proven to be the best system in several natural language processing tasks, but even then, there was too much hype around it, no? Even Elon Musk had to go on Twitter and clarify that he really wasn't involved on the management in OpenAI for over a year, right? So yeah, so and this is a nice visualization of what this consultancy company did in 2018 for the hype cycle of emerging technologies. And if we kind of zoom in, we can really see that deep learning, Internet of Things, virtual assistants, I mean, blockchains, all these, probably we're a bit past that, but certainly we're in the age of the hype of AI. So anything we deal with, we should probably deal with it in a sensible manner. Okay, so before I close it up, I think the message is, let's look at the technology we use today, if as practitioners or as consumers, with a with a critical eye. No, I think that's obvious and common sense. But now we know a little bit more of why we should do that. So we should ask or expect better explainability. We should ask and expect for more accountability and recourse when we use data science and machine learning models, and when we interact with them, in the hopes to have access to more fair systems that treat everybody the same way, regardless of their social and racial, gender features. And that being said, I think we're going to leave it here. So thank you very much, everybody, for following along.
Thank you very much, Luis. That was really, really very interesting. I certainly learned a lot in that session. So we have a few moments for some questions. Does anybody have any questions that they'd like to pose to the chat facility? Just give a couple of minutes for that. Love the K tweets example. Yeah, that was really, really interesting. I didn't know about that. That was, yeah, fascinating.
Because it was only online for, I think, 36 hours.
Okay. Doesn't look like we've got any questions coming in, but the application of AI in medicine and what the ethical implications are. Okay, are you able to talk a little bit about that?
Actually, I do. Before I joined Cardiff, I used to work for a startup in Spain that did data-driven solutions for health. So I think I was there for about a little more than 2 years. So the message there is, again, no, I mean, this might look quite obvious, no, but the technology is a support system, right? So as long as we can use the technology to ease up mechanical tasks while at the same time making the decision making more informed, and that decision making is ultimately made by health professionals, then we're talking. We see quite a few, news stories about AIs which are able to outperform human judgment in spotting tumors in EEG scans. Yes and no, no. So ultimately, what and this is something that was asked by Geoffrey Hinton, so he's one of the fathers of deep learning. So he asked on an open question: if you had to if you had to undergo surgery, would you prefer to be would you prefer that surgery to be done by a robot that you know has 99% accuracy, or would you prefer to be taken care by a human with the limitations and the imperfections that a human has? No? And obviously, most people answer that. Even with the limitations we as humans have, we would go for the human because we don't really trust yet the technology. So even though we hear a lot about it, it's quite early stages. So I think we will have to wait a little bit until we can really rely, and we are ready to rely on technology for health.
Okay, thank you very much. We've actually had a number of questions come in. I'm not sure we're going to have time for them all, but if we do another question here, it says, what is your view on the digital diagnosis of COVID-19 by answering a series of questions rather than a physical lab test? I thought that was quite interesting.
Sorry, I can't see that question myself.
Okay, just to repeat, so what's your view on the digital diagnosis of COVID-19 by answering a series of questions rather than in a physical lab test?
Well, I guess no, but that's something that's done anyway, no? I mean, I think that the word is triage. So when you, at least in Spanish, is triaje. I guess no. when you are admitted into a hospital, sometimes no, the nurse will ask you a number of questions about your fever, whether you're feeling dizzy or not, whether you've got stomach pain, and all this is done to discard certain major complications. So answering questions about your health, I guess, no, I mean, I'm not super familiar with that, but I guess that could be a way to discard potentially overlapping conditions. But I mean, I want to play it safe, and I would say that would not be enough to really diagnose COVID. But I mean, that's beyond my area of expertise. I see another question, and I'd really like to answer that if I have the time. It says, as a business graduate, how would you advise developing data science skills? Right. Well, I come from the humanities, right? So I can say a couple things about that. Learn programming, right? So learn an easy to learn programming language. And do a lot of exercises yourself. There are many courses out there. And I think learning with a purpose is very good. So if you like business, try to find a business problem and try to find business related data and try to learn and to develop your skills aiming at a vision. That vision, that purpose would be solving that problem or understanding better that phenomenon in your field. If you can do that, the motivation will be much higher. And whether it would be worth learning SQL or not, why not? But if we speak in technology, I would go for Python and the R programming languages. I think that would be a safer choice.
Okay, thank you so much. Unfortunately, I don't think we've got time to answer everyone's questions today, but thank you so much for listening and attending and engaging with us. We've had some really interesting questions there. The session is being recorded, so we'll make that available to you so you can listen again if that would be helpful to you. And just to say thank you very much, Luis, and thank you all for attending. If you have any questions, then feel free to get in touch with us. Okay, thanks very much. We're going to close the session now.
Thank you very much.
Thank you. Bye-bye.